All right, my last video, and hopefully my shortest, because it's going to be a really quick connection to what we did yesterday. But first, what is division, right? We're dividing things. So if we divide 4 by 2, take something, 4 objects, 1, 2, 3, 4, split it into a group of 2. How many things are in each object are 2, right? So that's the visual for that kind of stuff. So 4 divided by 2 is going to give me 2. But I can also rewrite this as a multiplication problem. Everything can be written in different ways, right? Like the number 8 can be written as a multiplication problem. It could be written as a division problem. It could be written as an addition problem, as a subtraction problem. So you can rewrite things in lots of different ways. So if I rewrite this division problem as a multiplication problem, I can do that, but I can't just leave everything else the same, because my answers would have to be the same. So what I mean by that is whatever operation I'm doing, I have to yield the same results. So 4 times 2 is 8, and the last time I checked, 2 and 8 are not the same number. So if I want to change a number, I still have to make it be the same thing, right? Like 9 minus 1 is a change, 4 plus 4 is a change, but they still represent the number 8. So if I want to switch division to multiplication, I can do that. But whatever I'm doing has to still give me 2. So I'm not allowed to ever change the answer. And I'm allowed to manipulate, right? So the question is, what will I have to multiply 4 by to get 2? Much in the same way, like 8 divided by 4 is 2. So 8 times what is 2? And you might be wondering, well, there's no way I can multiply 4 by something and make it smaller, or multiply 8 by something and make it smaller. And I'm using 2 a lot, but well, that's fine. And you can make it smaller. That's where fractions come in. So half of 4 is 2, and 1/4 of 8 is 2. So if you notice the relationship, and again, I'm only telling you guys this because I'm absent. You take the number that you're dividing by, and if you notice, that number is always going to end up in the denominator of your fraction, and the numerator is always 1. So if you want to turn division into multiplication, you can do that, but it's not like this. 8 divided by 4 is 2 is the same thing as 8 times 4 is 2. Like, that's not true. If you want to turn division into multiplication, you can do that, but you have to do something with what you're dividing by as well. So it's a change in the operation, and it's a change here too. So to switch division to multiplication, you keep the operation and the front number the same. I'm sorry, not the operation. You keep the front number the same, you switch division to multiplication, and you take what you were originally dividing by and make it the reciprocal. So if you forgot what the reciprocal is, or maybe you never learned, the reciprocal of a number is when it flips over. So 2/3, the denominator becomes the numerator, and the numerator becomes the denominator. So literally it just flips over. So 1/4 becomes 4/1, 2/7 becomes 7/2. That's the reciprocal. So if you think about the number 4, the number 4 is really 4/1. We never write the 1 there because 4 divided by 1 is 4, so it's just easier to write 4. But if you think about flipping it over, it's 1/4. So I could do something like 8 divided by 5/3 is the same thing as 8 times 3/5. We switch the operation, but if we do that, we also have to manipulate the fraction or this thing in the that's doing the dividing and flip it over. Okay, so turn division into multiplication by flipping and making the reciprocal of the second thing. So that, how does that help with what we're doing today? Oh, I used too much page here. There we go. All right, so how does that help us here? All right, same exact thing. We've got a division. So the first thing I'm going to do, I'm not going to do anything at all. I'm going to flip that fraction over, and what was downstairs is now upstairs, and what was upstairs is now downstairs. And now if you notice, this problem here that was division is now multiplication, and this is the exact same thing we did yesterday. So I'm just going to do a box problem where I see one. So I see a box problem up top. X of x. The first thing that comes to mind that multiplies to 6 are 3 and 2. 3 times x gives me 3x. 2 times x gives me 2x. Together that makes 5x, but I don't have 5x, and I need a minus sign somewhere in there, and I think that's going to be here. And so I'm going to take the top, make it x plus 3 and x minus 2. It doesn't seem like I need to do anything to this top one. This thing here, that 4x minus 8, is a box problem, but not like the traditional. It's only got 2 things with it, so 2 boxes. Split the 4 and the x. 4 and something makes 8, and so that's 2 with a minus sign. So I'm going to put the 4 and the x minus 2. Ta-da! And I'm almost done. Same thing with the x squared. Maybe I'll color code it a little bit. X squared plus 3x only has 2 things there. So again, it's going to look a box like this. So x squared and 3x. I'm going to put an x and an x here because that's what makes x squared. And this has to give me 3x. So if I already have an x here, that must mean there's a 3 there. So ta-da there. X and an x plus 3. And if you didn't guess it, hopefully you see it now. Cancel the things out. X minus 2 and x minus 2 makes a 1. X plus 3 and x plus 3 makes a 1. And all I have on top is a 3 and a 4x, and that's my pretty little problem, right? It's not as bad as it looks. Division is multiplication, so the upside is that it looks just like what we did yesterday. All right, I'm gonna do one more problem. I look very carefully at the term in the middle. That's division. Division, just the front fraction keeps the exact same. I'm going to take the reciprocal of the second one, which just means that the bottom becomes the top and the top becomes the bottom. And then I do a bunch of box problems. So I'm going to skip the box problem way. So hopefully you understand that I did a box problem to get that top number. And I promise you it's x plus 5 and x minus 3. I'm just going to skip doing the box problem. X squared minus 16. I'll do the box problem here. X squared minus 16. I could use my shortcut because I know that it's missing the middle. And when it's missing the middle, I know I've got to do same but opposite, meaning x plus and an x minus. The things that give me 16 are 4 and 4. But again, if you really wanted to do the box problem, it would work out. I'm going to skip the box problem for this one down here, but I promise you if you did do the box problem, it would give you an x plus 4 and an x minus 3. And the very last one, again, is a little bit of a different kind of box. 2x and a negative 8, split the 2 and the x. 2 times 4 gives me an 8, but we need a minus sign. And so now I've got this downstairs. So again, if you notice, like the problems are getting a little bit faster and faster because it's the same type of problem over and over. It's just box problems everywhere. So take this, box it, box it, box it, box it. And now I'm going to focus my attention on things that cancel out, that make ones, and you only get ones when you have the same thing on top and bottom. So I see an x plus 4 and an x plus 4. I see an x minus 3 and an x minus 3. An x minus 4 and x minus 4. What's left on top is x plus 5. Leave the parentheses or not. Put the 2 downstairs, and ta-da, there's your pretty little answer. Hopefully this video is short.